afternoon everyone. Today we will learn the ultrasonic waves. There are three types of waves. The first one infrasonic, second one is audible, third one is nothing but ultrasonic wave. Now what is the meaning of ultrasonic waves? Ultrasonic waves are nothing but the frequency greater than the audible range. Audible range is nothing but 20 kilohertz or more than that one is nothing but the audible range. Now we will see that there are three types of waves. The frequency suppose less than 20 hertz, that type of waves are known as infrasonic waves. The second one the frequency lies between 20 hertz to the 20 kilohertz, that frequency is known as the audible frequency range. And the third one, if the frequency greater than 20 kilohertz, that frequency is known as ultrasonic waves. So in short, we can say that the definition of ultrasonic waves is nothing but the frequency lies greater than the 20 kilohertz or more than 20 kilohertz, that frequencies are known as a ultrasonic wave. For examples, we are already familiar with the ultrasonic waves examples, just like a bat as well as whale. These are the examples of ultrasonic waves, or we can say that the sensation of ultrasonic waves with the animals, just like a bat and a whale, or dolphin also the example of a ultrasonic wave. Now how to produce the ultrasonic wave? There are two methods to produce the ultrasonic wave. The first method is known as piezoelectric method, and the second method is known as a magnetostriction method. In piezoelectric method, we will use for oscillation purpose the quartz crystal, and for magnetostrictions we will use the ferromagnetic material like nickel, cobalt, iron rod. Now we will see in details the piezoelectric method. First of all, the first piezoelectric method. The piezoelectric methods, we will use the quartz crystal. Quartz crystal having the three perpendicular, mutually perpendicular axes, just like suppose we will draw the structure of this quartz crystal. These are three mutually perpendicular axes. The longest axis is known as the quartz crystal Z axis, and the name of that axis is nothing but optical axis. Then the vertical axis is nothing but x axis. X axis is generally opposite two planes or the faces of a crystal. Acting along the two faces is known as electrical axis, and the third one is nothing but y axis. Y axis is known as a mechanical axis. Means in a quartz crystal, three mutual perpendicular axes. The first one is a x axis, y axis and z. X axis is known as electrical axis, y axis is known as mechanical axis, and the third axis is nothing but the z axis. The optical property we can study along the z axis, electrical property along the x axis, and along the y axis the mechanical vibrations along the y axis. Now in details we will see about the what is the piezoelectric effect and how we can produce the ultrasonic waves by using a piezoelectric method. Now first of all, piezoelectric effect. In piezoelectric effect, suppose we will consider this is the slab of a quartz crystal, and these quartz crystal slab we will place under the pressure. Then there is a formation of electric charge on both the sides of a quartz crystal. Also, instead of pressure, the same quartz crystal we will place under the tension. Then we observe that still there is a formation of a electric charges, but of opposite sign. Now, in short, we can say that what is the piezoelectric effect? Piezoelectric effect is when the quartz crystal placed under the pressure, then there is a development of electric charge on opposite faces of opposite side. But instead of the same glass quartz crystal slab will place under the tension, then there is a still development of a charges, but of opposite side, and this phenomenon of development of charges is known as a piezoelectric effect. Now here there is a difference between the pressure and the tension. Pressure is nothing but, we already know that, the force per unit area, and tension is nothing but the mass multiplied by acceleration due to the gravity. Now there is a difference between the pressure and the tension, and due to that pressure and tension there is a development of charges, but of opposite sign on opposite faces. Now we will see how the ultrasonic waves are produced by using a piezoelectric method. Before taking the productions of ultrasonic wave, the inverse of piezoelectric effect is also true. Now what is the inverse of that one? The inverse is that we will apply the electric charges along a certain axis. That certain axis is nothing but electrical axis, and then the quartz crystal can be stretched or contra along a y-axis. That y-axis is nothing but a mechanical axis. So we can say that when we are applied the electrical charge on a certain axis, x-axis, electrical axis, then that crystal can be stretched as well as contrast along a y-axis, and it undergoes to the vibrations. And when this frequency of electrical frequency as well as the natural frequency of vibration of a quartz crystal both are equal, then there is a resonance is produced, and due that is nothing but the ultrasonic waves are produced. Now we will see the piezoelectric oscillator. How to produce? By using a piezoelectric oscillator as a ultrasonic wave. Piezoelectric oscillator. First we will draw the diagram. Here this is RF choke, blocking resistor capacitor CB. This is RF choke which is connected to the wall diode V. This is our plate current. This is the grid. Here filaments, and this is the cathode. Now this grid is connected to the proper grid resistance, grid capacitor, and this one is connected to the tune circuit. And this tune circuit, C is a variable, L is that one, central tap is due to the connected to the cathode, and here this is connected to the center terms of that one. And exactly parallel we will connect it the quartz crystal to the tuned circuit. This is quartz crystal, this is L, C, Cg, Rg, these are the filaments, this is the grid, this is plate, and this one is a cathode. And here this is the high tension supply. Now the piezoelectric oscillator is also known as a Hartley oscillator. Hartley oscillator consists of here the RF choke, blocking capacitor, radio frequency choke, wall diode, grid resistance capacitors, and the tune circuit, and it consists of a quartz crystal. Now here, when the high tension supply given to the RF choke is a radio frequency choke, that radio frequency choke can be prevent, the radio frequency can be prevent and bypass the DC, and that current goes to the plate of a wall diode. Now here the second terminal of a wall diode is nothing but a grid, that for proper griding or grid bias of a wall diode through the grid resistance and the grid capacitor, and this grid capacitor connected to the second terminal of a tune circuit. Now what is the meaning of a tune circuit? The parallel combinations of capacitance and resistance is known as a tune circuit, and exactly parallel to that one we will connect the quartz crystal. Now here the filaments are not used for the proper grid biasing, and the cathode terminal connected for the ground terminal of or a negative of a high tension supply. Now exact working of that one, whenever the high tension supply given to the RF choke, here RF radio frequency choke can be prevent the radio frequency, and which is connected to the plate of a wall diode, and that DC current can be passed through the blocking capacitor. The blocking capacitors can be prevent the DC and bypass only the radio frequency, and that radio frequency given to the tune circuit. Now here the second terminal is a grid terminal. Grid terminal for proper grid biasing, here we will use the grid resistance and the grid capacitor, and that is connected to the second terminal of a tune circuit. Now here whenever this circuit is completely, we observe the second terminal of tune circuit connected to the proper grid bias, the one terminal given to the radio frequency 1, then we will adjust this capacitor in such way that the frequency of a tune circuit or a oscillatory circuit is nothing but f is equal to 1 upon 2 pi square root of LC, and here this high tension supply we are applied to that particular circuit, then the quartz crystal is also vibrate, and whenever the frequency of vibration of a quartz crystal is exactly equivalent to the frequency of a oscillator circuit, both are equivalent, at that time at the end of a quartz crystal there is a production of ultrasonic waves. When the ultrasonic waves are produced, when the natural frequency of vibration of a quartz crystal is exactly equivalent to the frequency of a Hartley oscillator, that is f is equal to 1 upon 2 pi square root of LC, both are equivalent, then and then only the resonance is produced, and that resonance is nothing but the maximum amplitude vibrations of a quartz crystal is take place, that is nothing but the ultrasonic waves are produced at the end of a quartz crystal. Now here how much frequency is produced by using a quartz crystal? Suppose V is nothing but the velocity of a quartz crystal, and that velocity is given by y by rho, where y is nothing but Young's modulus of a quartz crystal, Young's modulus of a quartz crystal, and that value is constant one, 7.9 into 10 raised to 10 Newton per meter square. And then the density of a quartz crystal, the density of quartz crystal is equal to 2650 kg per meter cube. Means both the values in MKS unit, Newton per meter square, as well as kg per meter cube. Now by using this velocity, we can calculate the natural frequency of a quartz crystal. That natural frequency we also know that according to the resonance or sound one, V is equal to NL or 4NL, where L is nothing but here N into 2T. Here T is nothing but the thickness of a quartz crystal, because here we will use, instead of length of a quartz crystal or length of air column, we will use the quartz slab, and which having a thickness as a T, and that value is equivalent to the N. So from this equation we can find the value of N is equal to V upon 2T. Now we can substitute the value of V from this equation. V is equal to, or equation number 1, V is equal to y by rho. So the frequency V is N is equal to V 1 upon 2T square root of y by rho, and denote equation number 3. And the frequency of oscillator circuit, F is equal to 1 upon 2 pi square root of LC. And here this is the frequency of a quartz crystal, 1 upon 2T square root of y by rho. Now generally instead of 1 we will write as a P also, P upon 2T y upon rho, where the P is a constant value that it depends upon the number of nodes. If the fundamental node is there, then the value of P is equal to 1 or K is equal to 1 and the 1 upon 2T. If the second fundamental node or second node frequency our aim to calculate, then here we will take 2 upon 2T y by rho. It depends upon the number of nodes. Now whenever the frequency, natural frequency and the frequency of a oscillator both are equivalent, then only there is a production of a ultrasonic wave. Now in this topic, first of all, we already know that the crystal structure or quartz crystal consists of 3 main axes, x axis, y axis and the z axis. X axis is nothing but electrical axis, y axis is mechanical axis, z axis is nothing but a optical axis. Means that our aim to study the optical property of a quartz crystal or Rothschild crystal or tourmaline crystal, then we can study along these 3 axes: optical property along z axis, electrical property along the x axis and the mechanical property along the y axis. Now the piezoelectric effect, there are 2 types of effect: direct effect, when we will substitute or place a quartz crystal under the under the pressure, then there is a development of charges, electric charges on opposite side of opposite faces. But instead of pressure, the same quartz crystal we will place under the pressure to tension. then also there is a development of charges, but opposite side, that is known as a, or that phenomenon is known as a piezoelectric effect. Now, the inverse of piezoelectric effect is also true, and that effect is when we will place or some quartz crystal, when we will take and apply the potential or voltage along the electrical axis, then the material or a quartz crystal can be stretched or contrast, or we can say that vibrate along the mechanical axis. And whenever the natural frequency of vibration of a quartz crystal and the frequency of oscillator one both are equivalent, then there is a formation of a resonance, and that resonance is nothing but a ultrasonic wave. Now here, by using the oscillator, first of all we will consider the wall diode. There is main thing is that consists of plate current, grid current, and the filaments and the cathode. Cathode used as a negative terminal, filaments for heating purpose, grid only for proper grading of biasing of a quartz wall diode, and the plate current. Now here we use the 2-3 devices. First one is RF choke. RF choke we will use for the prevention of radio frequency, that can be given to the plate of wall diode, and another one connected to the block resistor. Block resistance can be prevent the DC and bypass only the radio frequency, and that radio frequency we are connected to the tune circuit, and another terminal of a tune circuit connected to the proper grid biasing through the RG and the CJ, that is a grid resistance and the grid current. Now, whenever the high tension supply is on, then the frequency of oscillator, Hartley oscillator circuit, we get F is equal to 1 upon 2 pi square root of LC, and the capacitors of a tune circuit we will adjust in such way that the frequency of oscillator is exactly equivalent to the frequency of vibrations of a quartz crystal. When both are equivalent, then only there is a production of ultrasonic wave. And the natural frequency of quartz crystal we will calculate it by using the velocity of a quartz crystal is nothing but square root of y by rho, and the velocity in a sound one is given by V is equal to NL. The value of L is nothing but 2T, or 2T is equal to L. So, we can calculate the N is equal to V upon 2T, substitute the value of V as 1 upon 2T square root of y by rho. So, the natural frequency of a quartz crystal is 1 upon 2T square root of y by rho, and this frequency and the frequency of oscillator both are equivalent, then there is a production of a ultrasonic waves by using a piezoelectric method. In this way we can calculate or produce the ultrasonic wave by using a piezoelectric method.